Okay, great. So where we left off was talking about the knowledge graph. And just in general, over the last 15, 20 years, Google has been shifting more and more from not just doing exact text matches, because that doesn't always give you the best results, but actually trying to figure out what users mean in their search queries. And, the idea there is it's not always easy for users to clarify exactly what they want. So, do an example. So we talked about Galileo the other day, and so hopefully everybody, is kind of up to speed on who he is, which is great. And Galileo Galilei, and he would arrive in the following, had memberships in the following groups, right? So, for example, famous scientists, right? Famous Italians. He was Italian. Okay, so he'd be in that list. Famous anybody from 16th and 17th centuries, because believe me, we don't know that many names of actual people who, right, from that far ago. So it's actually kind of incredible that we still do. So famous anybody's from that era. You might also do astronomers, physicists, right? You might also people who got into trouble with the church, right? In case you don't know it, Galileo was threatened with torture and possible execution because way back when, the church had this dogma that the earth is at the center of the universe and everything else spins around it as part of God's great plan. But, Galileo came up with, among other, this scientific system that says, actually, you know what, we think the sun is at the center of stuff and planets revolve around it. And if you made a big fuss about that in those days, the church felt that you were challenging their authority and, with predictable consequences. Some of his contemporaries did, in fact, get burned for that stuff. So, anyway, so there's that. So anyway, he would have memberships with any of these lists, right? And if you're looking up topics related to any of those, he could plausibly arrive in any of those topics. And in fact, if we go to Google, and we look up this stuff. So for example, let's do famous astronomers. There you go. I can type now. If you do that, you'll get not only Galileo, right? But you'll get a bunch of other ones too. Some of these names you may know. I imagine just about everybody here has heard of Stephen Hawking, and probably many of you have heard of Carl Sagan. Anybody know about Tycho Brahe, what his claim to fame is? Well, he's an astronomer, right? But the big thing for him, well, I shouldn't say it's what he's most known for. He, all these guys, they did observations, they looked up in the sky and they saw where stuff was going. But the way he ended his life, so back in those days, right? So 1500s basically, if you were a scientist, you didn't go, to get funding from the National Institute of Sciences. You found some rich guy who was willing to sponsor your work. So, you found some king or rich business guy, whatever, and he was your patron. He paid your bills while you did research. Well, back in those days, they didn't have video games and they didn't have TV. So for evening festivities, a lot of what they did was have big parties, right? They'd have big banquets, big feasts, and people would, eat a lot and drink a lot and get stupid and all that. Well, in those days, if you were this guy, you were kind of like, if you were an astronomer, you were kind of like a trophy for your patron to show off, right? It was like, hey, look at this guy I got. I'm so cool. I own an astronomer, basically. And the astronomer, of course, being fairly dependent on this rich guy, wanted to make him happy, didn't want to be rude. So there was a big party, and Mr. Brahe was at the party and drinking a lot and really needed to pee. But the guy who was paying his bills gave a very, very, very long-winded speech, even by the standards of the time. And so Tycho, he's sitting there like, man, I really got to go, but doesn't get up and go because, it would be considered like a huge insult to his patron to walk out of the party while the dude's giving a big speech or toast or whatever. Anyway, eventually he has to pee so bad for so long that something in his guts ruptures and he dies of a horrible infection a few days later. So, moral of the story, if you're at a party and you got to go, right? Don't just, it's not worth it. All right. So anyway, astronomers. But all these guys, they belong to memberships, astronomers, right? And if you did other stuff like famous Italians, You know what? There's Galileo. He shows up there. Ooh, semifinalist for greatest Italian ever. How about that? All right. You could also look up, what, physicists. I bet Galileo shows up there. Let's see. Oh, I got to do famous physicists to get the knowledge cards. Yep, there he is. He shows up on a lot of lists. All right. So we see the idea that, again, any of these things, if a user is searching for people on any of these topics, Galileo should probably show up. He's a significant figure in history. And, even if the person isn't specifically searching for Galileo. And this sort of concept, it works with all kinds of other options, right? All kinds of other categories and memberships. For example, top songs of the 2010s, or what else could we throw in that? Famous baseball players, right? Or for that matter, famous athletes, right? People, for example, famous people generally. All right. And you can see that, again, you don't necessarily want to search in the exact terms of all the things you're looking for, right? For example, Oscar winner films, Oscar winners films, because that just happened lately. All stuff like that. It up results without having to have those exact matches, right, in that precise order. That's what we mean by using semantic search. Okay. Now, moving on. So that's all the stuff we're talking about. This is related to retrieval. So retrieval, fundamentally, when a request comes into Google, Google wants to deliver the search results, right? That's the whole point of why Google keeps all this information, is so that it can deliver it on request. Now, this algorithm, this whole retrieval algorithm, is a closely guarded secret. It's part of Google's special sauce. They don't want to give away too many details about it, because then they're concerned, the bad guys might crack it. And on top of that, Google fairly regularly makes minor tweaks to it to try to get it to run better, as basically they learn new variables that might work, or the old relationships sort of break down and they need some new ones. So Google is constantly always revising this anyway. But again, we've talked about some of these general principles, right? If you type in some search terms, ideally, yeah, Google would find those terms in the same sequence on the page. They'd be located in prominent locations. Google also considers semantic units, right? Term groups with specific meanings. For example, the phrase New York City refers to a particular place, right? It is different from just the separate words new and York and city. And of course, Google primarily relies on text, but also considers other web objects and even the metadata of those objects. Okay. Now, interesting question. We've already seen that many pages can have the same search terms in effectively the same location in the same order. So the question becomes, if many pages do meet that, have the same results that way, how should they be ordered? How does Google pick, well, this page should go above this page in the search results? Well, again, way back when, think like late 90s, it was basically about how often terms were on a page, where they were, right? Were they in headers? Were they in the page title? And were they located together and in the same order? So the thought there, again, ideally a page that was saturated with a topic. For example, if it was a page about baseball players, you would figure if the terms baseball and baseball players appear in multiple locations throughout the page, you can reliably infer that that's what the page is about. More so than a page that talks about, baseball generally, but isn't entirely focused on players, might have one section about baseball players, right? And the rest of it is, baseball gear, rules of baseball, whatever. So the idea, again, a page that's saturated with a topic, has many matches, would be assumed to be a better match than a page that just mentioned it once. Of course, also Google had PageRank. Remember, PageRank is this algorithm that says if a website is big with a lot of pages, that's a plus. If there are a lot of other pages on the internet linking to that page, that's another plus, right? But as we've seen, that model is easy to break, right? The bad guys just built big sites and they partnered up with their other bad guy buddies to cross-link all those pages to each other. And then those sites would rank pretty high on the PageRank algorithm. So a big motivation for Google to drive this semantic analysis, right, looking at the meanings of words, was to defeat that, right? Was to come up with something that the bad guys couldn't easily mimic, right? Or if the only way that you were going to have your page rank high is if it actually legitimately had content that matched what the user was looking for. So this is the phrase, things not strings. So string is computer speak for a long slug of text, right? That's what a string is, a text string, a sequence of characters. And so Google is trying to figure out the things that the user is looking for, as opposed to just finding pages that happen to have the same text string. So the idea is overall that Google is then going to retrieve better search results by seeing the meaning of what the users wants, as opposed to just grabbing any page that might contain the exact words, right? And that's all that stuff that we were talking about with Galileo, because a lot of people that, they might be interested in seeing a page about Galileo, maybe that's not how they're going to get to search to get to it, right? Maybe they're looking up famous astronomers. All right. So, for example, if you had a thing where, suppose you were looking for shoes, and suppose Google looks at the sort of pages that people who are interested, that are doing a search for shoes go to, right? And most people searching for shoes with Google are looking to buy shoes, right? They're not looking at the history of shoes. They're not looking at the design of shoes. They want to find a place where they can buy shoes. And so Google would recognize that the pages that people tend to go to and stay on for shoes have similar features, right? Things like they have images and with the word shoe embedded in the metadata of it. There are price numbers, right? So there are text strings with dollars or other currency symbols and a number following. They would have drop-down menus, right, for picking sizes and styles of shoes. All that kind of stuff, those are signals associated with an actual legitimate shoe retailer, right? And so Google could say, somebody went to the trouble to design this page in a way that makes sense for a shoe retailer, and we know that this page is similar to other pages that people have clicked on. All right, so they can do stuff like that. Now, sometimes relevance changes. We know, for example, there's one inherent change. For example, if you're looking for weather locally, like you do a search weather 60601, you're going to get today's weather, right? You're going to get some near-term forecast of what's going to happen. You're not going to get like historical weather data from the early 20th century. Likewise, if you do a search for stock price PFE, PFE is for Pfizer, it's pharmaceutical stock. If you're looking for today's, the stock price, you'll get today's stock price, right? You won't have access to a long run of historical data. So anytime you do searches like that, Google has figured out, based on what millions of people before us have done, that they're looking for current stuff. So they know these things. Also, changing focus, right? So if you did some search, if for some reason you looked up the search Russia-Ukraine conflict in 2021, that could be almost anything, right? That could be like Ukrainian nationalists. That could be like the famine that Ukraine had inflicted on it in the early 30s from collectivization. It could be something else, right? It could be just, maybe there's a boxing match, or maybe there's a riot at a soccer game. Who knows what you might get? But if you're searching Russia-Ukraine conflict, from last year, boom, that's what you're getting, right? You're getting all the stuff on the war going over there right now. So the question is, Google has to consider if there is an abrupt change in what people are looking for terms, right? So if those terms were as a search, 2021, Google delivers whatever it delivers, right? But now Google understands, if somebody's looking up Russia-Ukraine conflict, they want, recent news about the war, and they want maps, and they want casualty figures and stuff like that. So Google has figured, needs to be able to adapt pretty quickly if it sees a big radical change in what users are clicking on for searches. And of course, you can have local variations. So what users in Chicago are interested in might not be the same as users in another location. So suppose the Kardashians are appearing in Chicago for something, right? They're promoting some new line of makeup or purses or something. And a lot of Chicago's, if you search Kardashians, Google's going to figure, people around this data center, they're interested in their upcoming appearance. We'll give them some information about that. But people in another city far away at a different data center, they'll probably get just some information about where to watch, the next episode of their show. All right. Now, Google has to combine these two things somehow, right? So it combines historical information based on what people have done, what people have searched for, what they clicked on, all that, and then predictive models saying, maybe we have this time interval now, or this local bubble around Chicago where the people that are looking for stuff here, is very different from our historical baseline, and we got to make adjustments. All right. Another thing, factoring users' recent searches into results, right? So Google does, in fact, look at people's recent activity to determine what results it's going to show them. So if you go to Google, I'll get a new pad so it's clean, and I do what? Aha. See, this actually threw me. So I wasn't really paying attention to the Oscars, and like my whole morning lecture, when I did what, and these are the questions that came up, what channel is the Oscars on, what time are the Oscars, I assumed it hadn't happened yet. And then I found out, oh yeah, it was last night. So everybody in that class was probably thinking, what's wrong with this guy? That's what's wrong. I don't watch the Oscars. Okay. Anyway, but this is an example of actually where Google drops the ball a little bit, right? Because this is information that would have been really useful yesterday, but today not so much, but it still carries forward because, they don't have a lot of revised data on that. What time do the Oscars start? Yeah, they're done. Okay. Anyway, so if you follow up that what with what is, right? So what time is it, for example, whatever. But let's go back. I'll do what is and see what we get. What is my IP? That's always a popular one. Okay. Now, that's what it suggests, right? Because a lot of other people out there have wondered what their IP address is, and they go and they ask Google. But if I do a search on Google, I'll ask Google, what is Ethernet? In case you don't know, Ethernet is for wired connections. And there I have that. And now if I do a what is, Google starts offering me, oh, hey, you looked at all this Ethernet type stuff. We're going to give you some links about that. Aha. Okay, so that's something new. All right, so again, the fact that I've recently done a query about Ethernet has given Google some information that, oh, you're doing a what is, well, chances are you're following up on your earlier query. All right, now again, this algorithm too, it is complex, it is secret, it changes regularly, so Google, doesn't tell us all exactly how it works, but we know some things that we can just demonstrate by actually going in and trying it out. So number one, it's supported by actual search history, right? Your prior searches have an impact on the searches that Google suggests for you. Number two, also supported by actual clicks. So if you click on something in a search result, basically Google thinks they got it right and they're happy, and that confirms that their algorithm is working the way it's supposed to do. And we also know that rankings incorporate individual and global preferences. So if you start off a query by typing in what is, and Google doesn't know anything else about you because, this is your first time using Google that day, well, they're just going to give you the global preferences. They're going to assume you're like everybody else, or at least like everybody else around your data center, because they don't have any reason to think otherwise. But if you start doing more different searches, then Google has more information about you, and they say, oh, you're not just some dude who's looking for what is my IP, you're doing some research on Ethernet. Can help you out with that. Anyway, okay. Last thing, Google Instant, right? So Google Instant is what we just did right there where we demoed that Google offers up some search results, right? So you start typing in a search query and Google tries to help you out by finishing it. And this is actually really good for Google because Google has those search results cached, right? They know if other people have done it, they have those results right there ready for you. So if you say, oh yeah, that's what I'm looking for, guess what? Google doesn't have to do much work. They can just serve up immediately what you're asking for. And this is good because Google doesn't want to do the work, right? All that's electricity and time and stuff that they don't want to do. And it results in a lot of people having similar queries. So again, helps out Google. Now, you can do any of this other stuff, simple phrase like what is, who is, why does, and you'll see whatever's popular. So let's do a who is. Anybody want to guess who we'll see when we see who is? Interesting. Anybody else? I just found out that Brendan Fraser won an Oscar, so like good for him. So yeah, I would not have picked that to happen 25 years ago. Anyway, okay, let's find out. Who is hosting this? Andrew Tate. Yeah, Andrew Tate's in prison, or soon to be. I don't know who Tony Scott is. Who is Tony Scott? Yeah, I don't know. All right, whatever. I don't know. Yeah, I don't know these people. All right, but anyway, that's what you'll see. We could also do What is, well, I got the Ethernet for there. I need a pure tab again. I need to clean my tab. All right, let's see. We already did what is. Let's see, it clears again. Let's do why is. Why is my poop green? Yeah, that's some why. Wow, 2 questions about poop color in the top 10. All right. I mean, I guess it's an important question. Obviously, though, the reason why your poop is green is probably those Shamrock Shakes. So that, it is March. Okay. Now, again, the way this works, basically simple statistics, right? Google looks and says, here are some searches that are popular. Our best guess is you're like these other people searching for these popular things. So here's what it is. However, there is some filtering against defamatory and NSFW, not safe for work results. So 2016 election, right? You guys vaguely remember that there was a thing with Hillary Clinton and emails? Without getting into that, yeah. So she had a thing with emails. Anyway, although it also occurred to me while it occurred to me between lectures today that, wow, 7 years ago is actually like a really long time for all of you guys. But I'm going to hope you probably, remember this stuff. Anyway, so what it was, Team Trump basically said when they tried to type into Google Hillary Clinton scandal, Google wouldn't suggest it. And they were like, big tech is in the tank for Hillary. They want her to win. They're covering up for her. And it turned out that if you do the same thing, well, let me mention this. So if you do this, in fact, it's true. This is what happens, right? So if you do Hillary Clinton scandal, it's not going to suggest anything, right? However, same thing if you do Donald Trump collusio, it doesn't suggest anything there either, right? And the real answer, I mean, I'm sure, overall the sentiment at Google was overwhelmingly that they would prefer Hillary to win. However, this particular thing, this isn't about Google tipping the scales. This is about Google covering its own ass, right? What they want is they don't want somebody doing a lawsuit saying, Google directed people specifically to this stuff. Google suggested this when it hasn't been proven to be true. Because in fact, if you do the search, right, if you do Donald Trump collusion, you can type it in and it'll run the search and you'll see, whatever the collusion results are. Likewise, if you do Hillary Clinton email or scandal, you will definitely, find some stuff about scandal there. So whatever. But anyway, just for this, sometimes, people say it's one thing and it turns out to be something else. That's life. Okay, questions on any of this search stuff? Any questions at all? Any thoughts? Any topics I have not covered in sufficient detail? All right, well, let's move on then. So we got a second lecture to do. All right. Page indexing and retrieval. Bum, 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 bum. All right, I'm get another slideshow for this. So what we'll cover today is a little bit of this stuff, indexing, why it's necessary, and how Google makes it faster. And then over the next, subsequent lecture sessions, we'll talk about Google's actual indexing system. So first of all, Google is really, really fast, in case you didn't know, right? So a popular search on Google takes about half a second typically to deliver the first page of results. And an unusual search might take a second or two. Weirdly, I did a search today for talking about knowledge graph and stuff. Knowledge graph is all the web of relationships that Google uses to link those concepts together, like Galileo and astronomers and Italians. That's the knowledge graph. But I did another one. Famous baseball players. Sure, he's pretty famous. If you do this search, when I did it this morning, it actually took like 3.5 seconds to generate it. No, not famous baseball players. Famous Chicago Cubs players. Took 3.5 seconds. They got it a lot faster now. It must have been cached. All right, so we're going to try a different one. Anybody heard of the All Blacks? New Zealand rugby team? You have? Yeah. Okay. Oh, 0.6 seconds. Wow, that's incredible. All right. Well, anyway, I don't know what happened this morning, but when I did it this morning, it was like 3.5 seconds to deliver famous Chicago Cubs. I'm going to try one more. What's a movie that's in theaters now? Okay, I'll try Scream. Scream 6, I guess. Apparently, Showtimes. Let's see. Sometimes Showtimes take a little, but not today. Okay. So I don't know. I don't know what happened this morning, but it was an absurdly long 3.5 seconds wait. I was just seeing. I've occasionally had Showtimes also deliver really slow results. All right. Fine. Okay. So anyway, we did a bunch of searches and we found that Google delivered results pretty fast. And this is really impressive because the data keeps growing, right? Every year there's more pages. All of those pages need to be ranked against each other. There's more content per page, so the ranking process itself is more complicated. And of course, there are many more users, right? Well, the internet growth is kind of tapered off, but there still are more users. And they're spending more time on the internet, and they're all generating more content and more search traffic. So there's a lot more stuff going on at Google than there was, say, 15 or 20 years ago. And of course, the process itself is a lot more involved. And the way Google keeps up, of course, is by indexing, by making content easy to find in the first place. So remember, Google's basic technique is to match search terms to web page content, starting with text. Text is the first thing Google looks at. So when a Google bot scans a page, when it's going out to the internet and finding pages and sending the data back to Google, it captures all the words from the page and puts them into index entries. So basically, Google has this massive index from all the terms that it's found on the internet. And when a Google bot sends that page back, Google says, oh, here's the first word. Let's see if that page is already listed in the index for that. If it is, fine, nothing to do. If it's not there, it adds that page to the list. And it does that for not only for every word, but for every significant term group as well. So if you had New York City, the page would be added to the entries for New and York and City, and also for New York and also for New York City, which are both, semantic units. Anyway, from all that activity, from all the Googlebot searching pages and delivering the content back to the index, Google eventually builds up this massive index of search terms and all the pages containing those search terms. So we can do a super small example here for 3 oddball words with ZY in them. So we have syzygy, we have zygoma, and we have zizaba. And syzygy is stored in pages A, B, C, D. Zygoma is stored in B, E, F, G. And zizaba is stored in A, C, F, H, I, J, and K. Now, suppose a user enters the search query syzygy zizaba. Well, we can look at these index entries and recognize that both terms appear on pages A and C, and one term but not the other appear on several other pages. So chances are those 2 pages that have both terms are probably going to be near the top of the search results, if not at the top, right? We don't have enough information just based on this to know whether A or C should get the first place, or even if there's some other issues that might make some of the other pages with only one term show up higher. But regardless, when a user enters the search terms, Google has a very easy time digging out the pages that contain them, okay? And once those pages get selected, Google uses a ranking algorithm to determine which ones are delivered, right? Basically, all that sort of special sauce stuff we talked about before, saying which one of these pages is the best, which is second best, which is third best, and so on. All right. So why is indexing necessary? The short version is it saves a lot of time and work. So we'll do a human example. All right, so suppose you have a big stack of books and you wanted to find out which of those books reference Charles Babbage. Anybody know who Charles Babbage is? Was? He's a was. He's not an is. That's okay. He's an important guy circa 1900 in early computer development. So, but yeah. Anyway, so if you were looking some stuff up about Charles Babbage, wanted to find him, right? One possibility is you simply look through all the books, but that would be insane. That would take a very long time. So pick book 1, scan through every page, see if there's any mention of Charles Babbage, right? And then do the same with the next book and the same with the next book. That's a lot of work. That's going to take a very long time. And of course, if we're assuming that you're like a computer, that you have no idea who he is, and thus looking at the book titles isn't going to give you any information, right? If you knew who Charles Babbage was, then if you saw a book about the history of baseball, you're probably not going to think he's in it. But if you find a book called The History of Computing, you think, yeah, this is a pretty good prospect. Okay, but if you don't know, then you don't know. So the very fast approach then is to check each index, right? You go to the back, you look up the index entry for Charles Babbage. If there is one, great. You find it, you check whatever. If it's not there, then you put the book to the side and go to the next book. Now it does take a little bit of time to put together that index, but of course, if you're getting the same search over and over and over, this is the sort of thing you want to do. If you're getting a lot of searches, rather, even if they're not the same ones, but you build the index once and maintain it, it's a lot easier to do that than it is to have to search through every book for every search. All right. Now, next thing is about distributing. So in computer speak, a distributed system means that you have a bunch of different machines that are all doing part of a problem. Okay, so the idea here is if you have a big problem, you break that problem into pieces and you assign one piece to each computer. And that way they can all work on them in parallel, meaning they're working on the problem at the same time, and then deliver the results and combine them back and solve the problem that way. So suppose you have a very, very large stack of books. Once again, we're all humans at this point. So the stack of books is very large. Like most humans, you only have one set of eyes. In that case, even an index search could take a long time, right? If you got a lot of books, it's going to take a while, no matter how fast of a human you are. So one solution to that is simply to gather n people. Get a bunch of your buddies together, and every time a search query comes in, you give each of your buddies one small stack of books, right? Not the big stack, but a small stack. And so in that case, although the total work remains the same, the results get obtained about n times faster, right? Because each person has to do 1/nth of the work. And this is just how indexing works in a distributed system, right? So you might have a very large index entry, which might reference millions or even billions of pages. And when a search query comes in for that, right, that index entry gets broken up into slices. Each machine gets a slice. And although the total work is about the same, it's actually a little bit more because you got to do the breakup and the reassembly afterward. You get the results much, much faster because each machine is only doing part of the total work. All right. So we're gonna talk for a second here, though. It's picture time again. Okay. So step one, right? Very large index entry. Okay. And we say, wow, that's too much. We can't, we got to break this up somehow. So we break it up so that each of our machines gets a small slice of it. Okay, and I'm going to just copy that. Layer it. Boom, boom, boom. Okay, good enough. Okay. Each machine gets a slice of the entry. Okay, so this allows the problem to be solved much, much faster. But here there's a twist. I'm going to throw in a twist. Okay, and I'll mention at the end. Return a small portion of the list as top-ranked results. Okay, now, if you take out this step in the middle where you break up the machine, it's very easy to see that, for example, if this very large index entry, if you're going to return, say, the top 200 results, it's very easy to see that from one large index entry, you can determine the top 200 results, right? But how to ensure that from each slice, right? How to know how many results each slice should return to ensure you get the top 200 results overall. All right, so this is an interesting math problem maybe, except it isn't. It's not a math problem at all. There's no math involved. So how many top search results should each slice return in order to guarantee that you get all 200 top ranked results? What's that? Suppose you divide this into 1,000 slices, right? It looks like about 12 there, but suppose this is 1,000 slices. How many top search results would you have to pull from each slice to ensure that all top 200 make it into the batch here? And remember I said there was no math. Yeah, 200, right? If you want to absolutely guarantee that I get all top 200 results here, each of these slices has to return the top 200 that it sees in its own slice. Does that make sense? That's the only way you're going to guarantee it. Now, but this is one of those things where Google can trade off, a little bit of time versus perfection. Because if you've divided this index entry, which is very large, into 1,000 slices, it's really unlikely that one slice would get more than a few, right? And in fact, most people, Google really tries to have the results be like in the top 5 results. And if you say, you know what, the top 5 are what's really important. As long as we guarantee we get all top 5, that's probably good enough, right? So Google might just say each machine only has to figure out its top 5 entries and return them. And that's going to help speed the process along. They'll say, yeah, you know what? It is possible we might not get all top 5, whatever, or all top 200, but that's okay because, once you get past the top 10, it's mostly kind of junky results anyway. All right, now let's do a demo. I'm going to do a quick demo on that. One of the things, Google actually generally, so let's do, we'll do Chicago Cup. No, you know what? We're going to do something weirder. We're going to, what shall we do? We are going to do Doug Lundquist 2013 Web Analytics. Let's see what happens. I started teaching a course in 2013. All right, here's some garbage here. See, this one, they throw in some research stuff. They have some other stuff. It is MBA 590, so they're on the right track. And it very quickly, has nothing to say about me. Oh, there's a thing for a paper I did like 10 years ago. All right. Eventually, you start looking through some of this stuff, and it's just complete garbage, right? So this is just word salad here. They're clearly trying to pack their site with all sorts of oddball words. If I go a little bit further, let's see how far. 40 results, right? I don't know who this guy is. That's weird. March Madness. Some of this stuff is just not really, I have no idea how I'm showing up for this. Here's another one. This is Untitled, right? I would not click on this. It probably leads to viruses or not safe for work content. But you can see there, again, they're trying a little bit to have their text look like actual text, but it's just word salad that they're trying to get people to go there. Anyway, so like I said, you tend to not have to go very far into the search results before it gets kind of garbage. Even if I do something popular, let's do Brendan Fraser films. Boom, right? So we got some stuff for him. Even if we go to the end of him, it's probably not going to be too far. Eventually see some really weird stuff at the end. Although these extra searches tend to go a little longer. I'm just kind of seeing stuff. Yep. Yeah, maybe he does all have legit stuff. Because he's so much in the news right now. All right. Well, all right. That's fine. All right. Sometimes it does work, but if you did go all the way to the end, you'd eventually find some garbage stuff. I just don't want to spend the whole class doing this. Okay. Now, last thing, all right, this is the last slide we're going to do. So we're still doing our human example. We have this human search engine process with actual physical books. We're going to expand the problem to describe caching. So your search operations become popular. You have a lot of search requests every day. People are calling in to say, hey, or, can you find stuff in these books, whatever. Now, a few of these requests are very common and happen, hundreds of times a day. Like, who is Brendan Fraser? Or how much money does Bill Gates have? Stuff like that. Most requests, though, are much less popular. They're unusual. But let's also suppose one of the people on our team is super fast. And that person can remember all the results from the last 100 searches, whatever they may be. So if a search comes in that this person has already seen, boom, the results come back instantaneously, right? So that's nice. And what's the best way to use this talent? Well, number one, if you want to improve average search time overall, right, how fast you're returning the results, the simple way to do that is give the most popular searches to those persons, right? To those searchers. That'll make the most people happiest, because if it's a search that's coming in from 1 million people, you've just made 1 million people very happy, as opposed to if it's some search that happened twice a day, well, you're not going to make very many people happy by optimizing that. Because remember, this memory capacity is limited. Just like RAM is more expensive, Google's not going to put the whole index in RAM. They're just going to keep the most popular cached results there. So this is basically what this is. The other important consequence of that is that if you have this one person caching results for the most popular searches, that makes the most hardware available for other tasks, right? If it's a very popular search happening thousands or millions of times a day, then the fact that you can deliver that instantaneously without using much of your system capacity means there's more system capacity for everything else you want to do. All right. And this is a good break point. We'll call it quits here. If people have questions, I'm happy to answer them, but otherwise, come on back Wednesday. We'll talk some more. All righty. It's been a hoot.